Good evening to all and all. I would like to go with the fifth unit like thin cylinder as well as the thick cylinder. I would like to recap the previous unit 4 content. So one of our classmates would like to recap in the each topic in the what we discussed in the 4th unit. So let's see one by one.
So hi everyone, myself Mohammed Adil, basically a mechanical engineering student. So here we're going to see the recap of the topic, the end condition. So the end condition of the column. So the column is the member under the compression. So the way it ends, it fixed, and then it's called the end condition. So basically there is 4 types like pinned, and then fixed, and then fixed, pinned, and then fixed, free. So like on pinned, that the 2 ends can be rotatable. So and then on the fixed, the 2 ends are fixed tightly, so it can't be rotatable. So and then on the fixed free, the one end is free, so which is the weakest. So and then on the fixed pinned, the one end is fixed, the another end is rotatable. So this is all about the 4 types. And then here comes the equivalent length. So the equivalent length is the effective length, that is LE. So we have the 4 formulas like LE is equal to L. So which is for the pinned, and then for the fixed, LE is equal to L by 2, and then for the fixed free, LE is equal to 2L, and then for the fixed pinned, LE is equal to L by root 2. So that's all about the topic. The further it is continued by my friend.
My name is Ashik, and today I am going to speak about the evaluation of beams, deflection and slopes, and we are going to see about the Macaulay method. Now first comes the evaluation of beams, where when a load is acting on a beam, there is a slight bend, and the slope is calculated by the tilt of that beam, and the deflection is a vertical displacement. Now we are going to see about the basic relationship between the bending moment. That comes under the formula of EI is equal to d square y by dx square is equal to mx. Where now we are seeing about when this formula is integrated once, we get the slope, and when the formula is integrated twice, we get the deflection. And under the many bending points of the beam. And now we are coming to the Macaulay method. When we are using this method means when there are more points of bending in a beam, we can use this method. Whereas the problem solving speed will be increased and the solving capacity will be easier than the previous steps. So when this formula comes under the equations like mx is equal to raw minus w, where comes under the brackets of x minus a, where when the x is greater than a, this formula is applicable. If not, this formula cannot be used. And these are all the relationship between the bending moments of beam and deflections. And through the evaluation of beams and deflections, we are well known about the bending moment of the beam. And by using the Macaulay method, we can solve the problem easier. Thank you.
I am recalling a topic of Taylor's equation and slender stress in a strength of material column is under a compressive load, maybe it's under a bucking the long. So we use a Taylor's equation. The ratio is KL by R, where R is equal to root of I by R, where PCV is equal to pi EI by KL square, where E is equal to x smallest, I is equal to moment of inertia, K is equal to column length, L is equal to unstoppable column length. Further will be continued by friend.
Today we are going to recap about ranking formula for column. Ranking formula, it is also known as ranking Gordon formula. It is an empirical formula used in structural engineering. To determine the crimping load, which means buckling load. In the buckling load of a column, the ranking it is like unlike Euler's formula. Which is only valid for long slender columns. The ranking applicable is all columns for long columns, and the columns are failure by mechanical cutting, crushing and buckling. Definitions of the ranking formula: 1 by PR is equal to 1 by PC plus 1 by PE. The PR is equal to ranking crippling load and the PC is crippling load. and the formula of ranking formula PR is equal to PR is equal to alpha C divided by dot A divided by 1 plus A into LE by K square. Further, the topic is continued by my friend.
I am Marmadan. I am talking about column of strength of column. A column is a vertical structural member subjected to axial compressive. They are designed to transmit weight from the upper part of a structural founder. Strength of definite is capacity to relate the looks, bulking or crushing. Columns definition types. Columns classified based on their structural structure. Short column standard ratio falls by crushing. Under the long structural columns ratio failed by lower to crushing strength. A structural compression number can be vertical index column classified by their standard ratio. Thank you.
I would like to thank each one members. Everybody clearly explained the recap of each content. So let me start the 5th unit. Thank you all.